Example, there are the case. We have considered three cases. Okay? So this is before and there is the evaluation problem or the evaluation method what it does, it actually considers that a set of mode of the person or the state of the external process is given, which is is also that the objective of the evaluation problem is to find out this problem. What does it mean? It means that what is the probability that this sequence of states from the external chain will be observed? What is the probability that we will observe the emission of this outcome? A state from the external chain node observed chain that is called a symbol. So we want to know the probability of limiting this sequence of this. For example, when the Markov chain actually is shifting, is starting here, they are moving here, so an arrow is already here. From here it goes to here, to here, to here. So this is here it is moved, then so then there and there. Now, what is the probability that we will observe this one? We discussed this in the last class. Just to remind you, it is the probability that this sequence will be observed. Now, when the chain will travel in this path, what is the probability? Can you calculate this? What is the probability? This probability actually is the joint probability of two things. What are these? It is the sum of probability of all paths that end in a particular node. We will go there, that end in a particular node or state. We will cover this one later. For now, this probability is the joint probability of the first one. Probability of sequence of states visited in the, let's consider this as space. That means when this travels in this path, then we want to know what is the probability that the chain will exactly follow from S1 to S1 to S1 to S1 to S1. That means S1 actually, if you consider the states are sunny, cloudy, and raining, you can consider this is sunny, this is sunny, this is sunny, and this is sunny, and this is sunny. So what is the probability that the chain will exactly, the hidden chain will exactly travel in this path? The probability will be very simple. The first thing that we need to consider is that the chain has to start in a sunny state. What is the probability that the chain will start in a sunny state? Since for this algorithm, the initial state probability are phi1, phi2, and phi3. So this is the probability that the chain will start in the first state, which is actually here in sun. So we can write the probability that the chain will start in the sunny state is this one. This is clear. And what is the probability that this symbol will be eliminated? There is another matrix that is 5. Actually, this is the state number. We have a matrix there. This matrix actually is something like, okay, let me show you the matrix. This is the 5 matrix. These are the states. This 5 matrix, what does it say? It says that if the chain is in a sunny state, then the probability that this node will be 6.6, this node will be so, this 0.3, and this node will be there in probability quarter. When the Markov chain is in the states C, the cloudy state, the probability that the base node will be this 0.3, 0.5, 0.2. In the middle of the room, so we have seen this long ago, where when the chain is in sunny state, this node is going to be probability 0.6, this node is so probability 0.3, there the probability 0.1, and so on, right? So So if we consider that when the chain is in the sunny state, the Higden Markov chain, what is the probability that it will be actually limiting the symbol G? This probability is 1 is, and keep an idea is that when this is the sunny state phi is, then this probability
Still sort of coffee down there.
So collectively, what does it say? It says that the chain will start in sunny state and it will omit the limit.
আমি আমার গিটার থাকতাম না
The second thing is that, okay, sorry, please, I have to learn for now, just omit this one. Sorry. Now consider that the chain will be started in sunny state, then it will move to another sunny state. What is the probability? The probability will be a transition of the chain from sunny to sunny. So what we need to do is this one. Then what we need another transition from here to here. Another transition from here to here. And finally. So the product of all of these indicates what? The chain, the Higden Markov chain will travel in this path. This is clear or not? So the product of this one is the Higden Markov. This product is S below. That phi S time phi SS PSS, PSS, and PSS, and PSS. So this probability represents that the chain will travel in this path. And now we need to consider the probability of sequence of symbols imitate in the path. When the chain is here in sunny state, the probability of imitating this symbol is this one. This comes from the matrix we'll see later. When this is here, this will be phi S. When it is here, the symbol is S. The probability is phi S SS. When it is here, the symbol is B. Probability is chain is S, sunny state, and the symbol B is similar to. So do you understand that the sequence of symbol is generated with probability this one times, this one times, this one times, this one. So we can write phi S T times phi S T, phi S T, and phi S T. So now, what is the probability that both of these trains happen? This is the product of this one. So do you understand this? Confusion? Yes. Now, which one?
Sir, the phi's.
So, fine, okay.
Why
do you understand what do we mean by this one? This is the first question.
Yes, sir.
You understand this one?
Yes, sir.
Okay. Then, this says the probability that when this Higden Markov chain is in this state, a sunny state, this says the probability that this mode will be. Then, when the chain is here, this mode will be the same probability. When the chain is here, the base mode will be so is this one. And this mode will be there, here, and there. Now, what is the probability that this mode will be a sequence of this? And this probability of this one times probability of this one times this one, and this one. That's what actually is here. Right? Now, when we combine these two, what does it mean? It means that the Higden Markov chain is traveling in this path. And when it is traveling in this path, it is emitting this sequence of symbols. Then it will be the product of these two. Now, what is your question?
Sir, you wrote phi SG and phi SG for all the products. Shouldn't it be?
Just so. This one. Which one? This one.
Yes, sir.
Okay, let us focus here. Which one?
Sir, the last two terms in the whole product, shouldn't it
This
be?
one?
The last one should be phi B and phi B, right? But you wrote phi g and phi g.
In the second line, sir, not that line.
Yes, oh, it's a mistake. Great. It should be actually how many? 1, 2, 3, 4. What is missing here, right? Yeah, it should be
SS.
So.
great.
Phi SS.
Yeah, it should be SS, it should be P, and
Another
another T.
Yes.
Right?
Yes.
This is the case. Now, what we can do, we can rewrite it in little bit. What is that? Let me write it here. Into this, within this block. What is it? The chain starts in a sunny state. Then it emits a simple G. Then it moves to another sunny state in the next time. And it emits another simple G. Then it actually moves to the next state which is also sunny. Then at that point it generates the symbol which is SS, right? Now it moves on to another sunny state. This time it generates a symbol which is that, and finally, right? Then we can, now if we focus here, what does it say? It says, now coming back, it says that the chain starts in the state 1, the sunny state, and emits a group symbol. That means let's denote this one by a variable alpha 1. What does the variable mean? It just means that it starts in the first step, in a state 1, that is the sunny state, and it simultaneously it means that it actually follows this observation order. Is this clear? Then for this point, what we can write? Alpha 1 C, right? This is, if you consider this is a cloud state. And what it will be? It will be the chain has to start with cloud state, and it has to generate a symbol G in the cloud state. Similarly, for this one we can write alpha 1 R is equal to we understand this or not? Once you understand this, now yes. So we have alpha 1 here, right? With S. Alpha 1 S is here, and alpha 1, sorry, what is this? Alpha 1 C is here, and alpha 1 R is here. Now, if we want to write alpha 1, alpha 2 S here, the question is, what should be alpha 2 S?
Alpha 1 is into phi of.
Okay, just if we focus here, if this one is alpha 1, then up to this alpha, right? Up to this. So what we do, we denote this one by alpha 1 S, and the transition from S to S is here, and alpha phi S is here. So the first side, we can say it will be alpha 1 S times the chain goes to the second state, it has to be in the sunny state, so the transition from S to S has to occur. And it has to follow these symbols. First it is G, here it is G as well, based on our assumption. So it has to be phi S G, right? Question is it all or will be more?
So
All
bit close.
That depends on the definition of the variable. What do we mean by this? Alpha T. Definition of alpha Ti is actually it is the probability of all paths that ends in a node I in the T step. Right? So for us, what we have actually alpha to S. This means the probability, in fact, sum of probability of all paths. Actually, path is not a widely used term here. We are using it just to understand it clearly. All paths that end in state S. How many paths are here? This one actually, this one, not only that, it has a second condition and observe up to OT. And actually it's second bracket is a better example. So if it is OT, that means it has to observe the sequence G, it has to observe the sequence G. So this alpha now we can define it, alpha to S is the sum of all probabilities from here to here, here to here, here to here. At the same time, we need to mention that when we are here, we observe this symbol. When we are here, this one. When we are here, we observe this symbol. If we write this way, then this equation will be this path. What is the equation? That we start here, that we travel from here to here. What is the probability? Yes. And we have a symbol here, which is G. What is the probability? Phi S. Then what we need here? Phi S G. But since this actually is the sum of all probabilities of all paths, they are ends here. So we need to consider this path as well. When we consider this path, then it starts with the probability what? Alpha 1 C. And then it has to have a transition from here to here. What is that? Then again, we have to observe this symbol. Similarly, we need to consider this one. A transition from here to here with probability PR2. Yes? And so what we can write here is alpha 1 R PCS. Right? Very good.
So the first one is why do you write those?
Oh, the first one actually now. What is the problem with the first one?
So you wrote it twice, like phi SG.
Oh, I remember. Okay, sorry. Great. That's good. Because you are following me. Very good. That's what I want. I need to make mistakes, right? Now, the next job is, what is our next job? We want to write a generalized equation. We can write it either as alpha. We can write it as alpha t, and we can consider the state is j, then this will be better. Or we can write it as alpha t plus 1. Just this is a choice of the use of variables. When you have this one alpha t, then this one will be what? T minus 1. When it was 2, then it was 1. If you consider alpha t, this one will be alpha t minus 1. When this will be alpha t plus 1, this one will be alpha t. So what will be the equation? Just help me. We want to write the equation for the generalized equation for alpha. And we will consider the states are j. I j1. Then
Summation of the product.
how many paths are there? How many paths can start?
So number of possible states.
The number of states in the Indian approach. So from each of the states, one path can start. Because a path actually cannot have a cycle. So we can have at most how many? 3 paths. So we can write here, what is the equation? Then this alpha 1, alpha 1, alpha 1. For each of these states, we have one alpha value from the last step. Then it will be what? Alpha, if it is t plus 1 t, then it will be t minus 1. Following the x, let us consider this is t, then it will be t. Right? Alpha t. And what will be the state?
I.
Then we are considering one important thing that time is. We design the forward algorithm in such a way so that we will accumulate the path here. When we consider this S2 here, alpha 2 here, we will never consider this starting point. Always there will be transition from here to here, here to here, here to here. That's why if it is alpha 2, this one will, sorry, alpha 3, this one will be alpha 2, this one will be alpha 1. So, if it is alpha 2, then we need to know alpha 2 which state, this one, or this one. And then, there should be a transition from I to the next state. The next state is what? J. If the current state is I, next state will be what? J. So there will be a transition from I to J. For example, here we have S to S, C to S, R to S. Okay? And then, in the final state, here or here, whatever you consider, there will be a emission of this symbol. Which state?
I.
T plus 1. If it is T plus 1, then by T plus 1. And what symbol will be omitted? I made a mistake, right?
I.
What is the state? J. The state is J, but the symbol that will be immediate will be OT plus 1. Why? Let me clear this. This state is what? When we were here, we calculate this one for S. Always the symbols are emitted from this state.
The current.
Yes. So whatever variable we have here, we have this one. Now, the sequence we consider here is what? This one is G, this one is G, this one is SS, right? So if we consider the variable is defined as O equal to O1, O2 up to O-B, then this one will be the state for which we are calculating to have a church. Is this clear? So once we have this one, then the algorithm is done. The algorithm is done. In the book, the algorithm actually is solved in a recursive way. Students, last time when I examined the paper, actually you will find many matrix based solutions are there. These solutions are more or less easier than the iterative solution. You do not need to actually deal with the individual indices. That means I, J, K, you do not deal with that one. So matrix operations are faster and simpler. So we will first see the recursive algorithm for one step, then we will move on to the matrix. And if we understand the forward algorithm, then we will understand the backward one, then we will understand the B one, and all the learning programs all use the same algorithms. So one thing that actually we will understand here, this variable, what is that variable? This actually includes all the paths that ends in this. So if you consider here, then the paths will be this one, this one, this one, this one, this one, this one. How many paths will be there? 9. All 9 paths are accumulated here. So once you have the value for this one, alpha d I, then actually if you move on to the next step, you do not calculate the probabilities like here individually. the values are accumulated and you move forward. And in the end, you will have only 3 nodes to consider. There will be 3 values, and we will just sum them up. If you sum, if you consider this probability, if it is the last node here, then it is the probability of all paths that ends here. This is the probability of all paths that ends here. Then sum of these 3 will be what? Probabilities of sum of all paths. By this way, the algorithm just reduces the complexity. If you want to, you can calculate the what's the brute force using the brute force method. You can segregate each of the path and then calculate the probabilities. For example, for this algorithm, if there are n steps and t steps, that means you measure 1 to up to t, then the complexity will be 2 times t to n to the power t. Now consider there are 3 steps and hundreds. The 3 to the power 100. You understand 2 into 100 is 10. On the other hand, the complexity, if you use the forward algorithm, it will be how much? 900. So it reduces the complexity very, very hard. So then once we understand this, the algorithm actually, what is the given things for the algorithm? This system actually is known to us. We assume that the quantities that are given is a matrix, we call it P. That means lambda is given. Lambda is P, phi, and phi, right? That means the matrix P is given. I am not writing it here because we have it. The matrix phi is here. It is an n by n matrix, n by n. This one is n by n matrix. The vector pi is given. Then, what are the other things given? The value of p is given. That means for how many steps you will observe the Markov chain. Another quantity is given, that is the output that you observe. So all of these are given. What we need to do, the algorithm is very simple. I am not going to the step by step as explained in the book, you can read it. We will go to at a faster way. So the algorithm requires some initialization. What is the initialization? The algorithm requires that you set the value of alpha 1. J. Alpha 1 j is equal to pi j, right? Pi j and the probability that the symbol O1 is indicated in the this is not this is J. This is J, right? This is the initialization, and you need to initialize it for all states of the J. If there are 3 states, then what are the induction states? The induction states say that you need to calculate it for the P plus 1 steps. So you need to set the value P equal to 1. If P is equal to 1, then P plus 1 is what? 2. Then you need to set it for each of these steps, let's say J. It will be what? Summation of I is equal to 1 to n for all states alpha t into I. This is I. Then probability be I to j, phi j, O. This is clear. Then you need to. Sorry?
O of t plus 1.
Yes. It should be t plus. It should be t plus 1. capital T, that means you already calculated the probability for the last test. So what do? You actually, following the algorithm, let's make it simpler. If T is less than T, you need to go to step 2. That means from here, after updating, we go back here. Else, you follow this step. And here actually, you need to calculate the probability of O we have lambda, which actually is equal to what? What is the probability? Say, when you have calculated this one, alpha T for S, alpha T for C, and alpha T for R. That means all the paths that ended in this state are the probability is here. All the paths that ended in this state probability here. So now we want to calculate all paths. That means this one will be this plus this plus this, right? And so we can easily write this probability is I equal to 1 to n alpha T what? That's all.
So what is capital T? What is capital T?
What is capital T? Right here. The capital T is how many steps the Markov chain will actually have transitions. 1, 2, 3. This can be, when we consider that B is more, what is the value of T? High, because we consider only G, S, B. So we consider the Markov chain for 5 steps. Okay? Can I jump? Now the algorithm is explained here. If we go to the example, let me show the example very simply. The example remains the same. So we have consider the B's mood, and mood is good, bad, this one, and we have the assumptions that the chain will start in each of these steps with an equal likelihood. Okay, if this is the case, then the P matrix is this one. Following the text, you will find it. If currently it is in S state, probably S, then C, then R. This one is if currently it is in the state S, the probability that the base mode will be good, so, and bad. Probably Y is this one and O is this one. All the informations are given here. T equal to what? 5. Set করে নিন আমাদের আমি লিখতে কাজ করলে So initialization, let us initialize here. So in the initialize state, what we will do? We will write what? Alpha 1 will be what? Phi S, right? What is the value of pi sub S? What is the value of this one? This is that the current state is S and B's mood is good. What is the probability?
0.6.
Right? There it is. Point. Then alpha 1C will be 1/3 into what? Because so the chain starts in a cloudy state, and from this cloudy state we find that which mood is good. So phi CG, which is this one. Finally, alpha 1R will be pi R, phi R, right? This will be 1/3 point Now, if we consider the step 2, let's do it here. Then we need to calculate the values of what? Alpha 2s, alpha
We
2
said always
C,
calculate always
alpha 2. What is alpha 2s? Just consider this diagram. What is diagram? This one. Alpha 2s will be the sum of this one, this green line, and this green line, right? Alpha 2s will be this one, and this one. You can recall. So, what we can write here, alpha 2s is equal to 11. So what is alpha to s is, can you spell it? Alpha 1 is times a transition from s to s and phi s plus alpha 1 c, a transition from c to s, then phi s plus alpha 1 r, a transition from r to s, phi s,
This is the last
phi r, right? This is phi c.
last
No, it's okay.
Yeah, it should be
Phi s.
first.
This equation is okay?
Yeah.
Then what we can write? Alpha s is what? 1, 2. Into what? A transition from s to s. What is that? 0.5. And what we do, just let us become a bit intelligent. This phi s g is everywhere, right? Let's make it common. What is this value? Phi s g is?
0.6.
Then 0.2 multiplied by 5. Point in plus 0.1 multiplied by what? A probability from C to S. What is that? Plus 0.033 into a transition from R to. What happened? Wrong? That's why actually I said at that time, but sorry, the actually is getting older. So, okay, let me write it. This alpha 2. Let me write it here. Sorry. Actually, this Firefox actually is asking for buying the system. Alpha 2 is just let us write the value now. What is that? Alpha 1 is. What is the value of alpha 1 is? 0.2. Into a transition from S to S. 0.5 plus alpha 1c. What is the value? 0.1. A transition from C to S is 0.4 plus alpha 1r, that was 0.033 into a transition from R to S. What is 0.2? This one multiplied by phi st, which is 0.6. Okay, this is the, okay, let me write the result. The result actually is 22. It is here. So you have have these PSS, they have a different order, doesn't matter. Right? Then alpha to C, you can do it here, alpha to R, you can do it similar thing, right? And then you can calculate alpha to alpha 3, I. Then you can calculate alpha 3, alpha 4, I. This I actually is sunny, cloudy, rainy. And finally, when you calculate alpha 5s, I am not repeating it, then actually you have these probabilities. And eventually, the sum is, so this is the probability that we observe the sequence G, Z, S, E, do you understand? So this is the very silly first year, second semester type kind of stuff. What is it? Now, we want to do a bit bigger. We want to learn this one from a matrix operations perspective. So that's what I wanted to write here. Now, the first step was, let me write it again. When we write alpha 1s, alpha 2s, and 3. This one we have alpha 1 times or you can write, actually this is phi s, this is s, and alpha 1, actually G is coming here, so this one is phi s, G, phi c, G, this one is this one is C, this one is R, phi R. Right? Now, if we define this one phi, and if we consider this column, then these values are simply what? The product of the corresponding entries in the two vectors. Then what we can write that alpha 1 is a vector which is the product of phi and the first column of the phi matrix. Let's say a superscript indicates the first column and subscript indicates the first row. We denote this phi 1 in such a way, it actually is a vector of a matrix. And it's a column of a matrix representing a vector. Which column? The first column. Now, the question is, do we have an operator that actually multiply corresponding element of the vectors? We are very familiar with the A transpose B, right? Which actually is the, we use all the time, this is the dot product. Right? Here there is fortunately an operator which is denoted by a circle. We call it, I cannot recall the exact one of the spelling, Hadamard product. Take this spelling, this Hadamard products, what it does, when the operands are either vector or matrix, what should be in the same what should be of the same dimension, then instead, what it does, it multiplies the corresponding element. So this has the same dimension. When this is a vector, this is a vector of same dimension, corresponding elements are one. This is a very Rayleigh matrix operation. You can do it by this way. You understand Hadamard product? If you just search Google, you will find it. Hadamard product. Or you can be a bit tricky. What you want to do? You want to multiply this element with this one, this element with this one. Then what you can do? you can actually create three separate matrices, where these elements of the matrix will be the diagonal elements of a single matrix. For example, here, instead of this one, what we can do, we can make a matrix phi G. What does phi G represent? It represents the first column of the phi matrix where the elements are actually placed in the diagonal. Something like this. 0.6, 0.3, 0.1. All are
0.
Then it is the standard matrix multiplication. Because when you multiply this one with phi 1, this one actually is multiplied by this one is multiplied 0, this one, only this one is multiplied as this one. Second, this one is multiplied with this, and third this. But what you need to do is, when you will write this one, if it is a standard matrix operation, then you can write it. For example, this Hadamard product, as long as you mention that this circle is the Hadamard product, everyone knows it. But if you invent some operation and you do not mention it, and more, the results do not match. When the result matches, then it forces me to check it. If the result does not match and you invented some operator, then most of the cases I will, even though your process is good, but you invented an operation, but you did not explain what is the operation, then I will not actually invest on this. Is this clear? No one will. Unless you mention that this is this operation, and then I was hoping this operation. If the result does not match, it doesn't matter. Because the multiplication, typing, these are very silly things. Plus 2, 3, 5, 11. But you need to do it. There are marks. Okay. Then we can write what? Alpha 2. Now alpha 1 is a vector. This is a single variable. This alpha 1 is a vector. And alpha 1 actually is a vector, and it represents all three elements in the vector. Is this clear? Now, if we move on to alpha 2, what will be the value of alpha 2? If we can find out the value of alpha 2, then we are done. What is that? Look at it. What is this? The probability, if we write here P, S to S, right? 0.5. What is 0.4? C to S. What is 0.2? This is the transition probability matrix. And actually, what is this one? These entries are alpha 1. If you actually just multiply this one, then what is the value of alpha 1? If we write alpha 1 say here, then alpha 1 is this matrix multiplied by 0.2. 0.2? No. 1/3, 1/3, and 1/3. Then it will be, the values will be what? 0.2, 0.1, and 0.033. Right? Now, this 0.2, 0.1, and 0.033 is a matrix. What matrix? And corresponding elements are multiplied with what? How can we get this?
The first column.
How can we do that? So, if we, what should be our operation? forget about this one. If we want to get this summation, then how can we get this? If you get the transpose of this matrix and you multiply this one with alpha 1, then the transpose directly comes here. What is that? 0.5, 0.4 and 0.2. Then this 0.5 will be multiplied by 0.2. This one. 0.4 will be multiplied by 0.1, this one, and 0.2 will be multiplied by 0.03, this one. And this will be the first entry, right? And when you have this one here, 0.3, 0.4, 0.4, then you see 0.3 will be multiplied by 0.2, this one, 0.4 will be 0.1. Right? This part actually is already as a vector. And we need to multiply this with what? This vector. Either we will go for the Hadamard product or we will go for the invented matrix, this one. So, what we can write, alpha t will be this phi, what? G. Since the second step is also G, then you can write here. Okay, let's write it plus 1, then plus 1. This one. This one will be multiplied with what? P transpose alpha. But this one should be done first. Right? So what we can do, we can write that, okay, you can write this in this way, or you can calculate it an intermediate vector Et plus 1, which actually is the P transpose, then alpha t, and then your alpha t plus 1 will be 5 4t plus 1 times and if we do that, let's jump into alpha 2. Then let's calculate this one, E2. Okay. Let's calculate E2. E2 will be what? This transpose. What is the transpose? Well, the transpose is here, right? We already have this one. E2 will be 0.5 times 0.2, which is 0.1. 0.4 into 0.1, this is 0.04. Then 0.2 into 0.03, this is 0.066. The summation will be
0.206. 0.206.
But I think we missed something, right? Point 033 into 0.2 will be what? 66006. So 1466. So this will be, then it will be 0.1466. Then the next entry will be this one multiplied this one. This is 0.6. This one is 0.06. This one is 0.04. And this one is 0.0. Something like this, right? And the summation will be 0.0231132, right? 0.1132, and you try the last one is 0.0732. Once you have this one, then this one will be what? 0.6 into 0.3 into 0.1 multiplied by 0.1466, 0.1132, 0732 and 0, 0, 0, 0, 0, 0. You multiply, then you will find the values are 0.0879, 0.0339, then 0.0038. Okay, if these are the values, then we can check it. The first one is 0.088, done. Second one is 0.034, done. Third one is 0.007. Oh, I have the same value. This one is 0.007. This value is 0.007. So, if we just write down the forward algorithm in the matrix form, let us do it in question. What is that? We need to initialize it. The initializations are what? Okay, what are the given things? We need to start with the given things. P is given, phi is given, pi is given, O is given, and T is given. All these are given. So once these are given, then you can calculate the alpha 1. Once you have the alpha 1 is what? 5. Then
Pi into pi.
Then or you can have the Hadamard product. The first column of the or second column, third column, based on that. And then you need to set T equal to what? You do not need to set T equal. Then once the initialization step is done, then the second step or the general induction step will be what? Alpha T equal to 5 T plus 1 and then E plus 1. What is ET plus 1? Is P transpose
Alpha T. Alpha T.
then as long as then you update it in the update you will make T equal to T plus. If T plus 1 already, if this T already reaches to T, then you sum. What is this probability? It will be the probability of what? In general, you can write alpha T 1 plus alpha T 2 for all stability sum. What you can write this? Alpha T C. What is C here?
120.
C is the column vector with all elements 1. If C is the column vector with all elements 1, then actually it just sum on the element of the other vector. Any questions here? So once you understand this one, the chapter is done. Any questions? This is a very good algorithm. In that sense, actually, mathematically you can solve it. This is the final set of values of alpha T. Here it is alpha 1 S, here C.2, alpha 1 C.1, alpha 1 R.03. Then alpha 2S, we have seen it, this value we have already seen, right? Finally, when you have this one, and by adding this, you can get the actual results, right? So, any questions here? Then we can go to the backward. In case of the backward algorithm, the values in the forward algorithm that the observed outputs are also considered. Now, then we are moving in which direction? The backward algorithm moves. So it starts here, then it comes here, and it defines a variable beta. So if we consider it similar to alpha t, what should be its value? What should it represent? Is the question clear? When we consider forward algorithm, we have alpha ti. It indicates the sum of probabilities of all paths that ends in node I in t steps, and we observe all the outputs up to t steps. What should this represent?
Sum of all probabilities
Sum of all paths.
that enters
That
enters from the
intersexually is will confuse you. Can you take it?
That we can travel from I. Some of other words that we can travel from I.
Yes. So, in case of the forward algorithm, it includes all the paths that ends in this line. The backward algorithm does it in the opposite way. We consider all paths that start in the step I. So, from here, one of the paths is this one, this one, this one. Right? All paths. And you can have to consider this one, this one, this one, this one, this one. So all the paths there started from the state I. And once you have this one, then actually we are done. Let me write down the algorithm and we will be. So what are the given things? Once again, we are given matrix P. 5, then O, right? And we start with the algorithm P is equal to, since we move to the backward direction, and then immediately we will not consider the recursive one. The recursive one is available in the book. So we consider the matrix one. So beta D will be what? That means always you will be ending. Only one important thing is that. So if beta t, that means, for example, if we have t step here, beta t is equal to 1. Then one thing is missing here. What is that? It does not consider the, for example, these x are t, observation t, and s. It is defined that this probability has not been integrated here. Right? So in the forward algorithm, when we consider this state, we consider the symbol here. But in the backward algorithm, when we are here, we do not consider the symbol here, but we consider the symbol up to here. Then, when we calculate beta t minus 1, the section is beta 2, for example, this one, then we consider this transition probability, what is that? ESS, and the symbol emission probability, this one, and the inverse, this one. That's why what happens, this, after this initialization state, we have the beta t equal to what? We consider, let me write it, beta t plus 1 multiplied with the symbol emission, that means 4t plus 1 final state. And this one is multiplied with the transition probability. This time we do not need to take the transpose of the matrix. What actually is here, just let me write the first one. It is 1, 1, 1. And this one, what symbol was actually observed here? Let's say the symbol that we observed here is S. So what is the probability of S? You can get it from here. S is 35. 0.3, 0.5, 0, 0, 0, 0, 0, 0. So this one actually is this one actually is that in this state where here we are here and we observe this symbol. This one actually is what is the result of this one? 0.3, 0.5 and 0.3. This one is multiplied with this probability, transition probability, which is what? 0.5, 0.3, 0.2, 0.4, 0.2, 0.2. Now, whenever we have this one multiplied with this one, this gives the beta 2 here. This, when this one is multiplied with this one, we get the beta to C and so on, right? By this way, we move to the initial state. When we come to the initial state, then we get the beta 1. What is missing here? The beta 1 actually considered all the observed values here, and what we need to learn, the transition probability here, beta 1 does not consider the starting R and the phi R here. That's why what we need to do is beta 1 has to be multiplied with and this one will be actually multiplied not in this way. This alpha 1 transpose will be multiplied, and this one will be this one, then they will be represented as here. There is one. No. We get beta 1 here. Beta 1 is actually 3 probabilities 1, 2, 3. And what we need to do, we need to multiply this one with this phi 1 and phi s, g, this one and this one. Then actually we need to do it in a two step. This one actually is a vector that we already have forward. Then the final probability will be found in a single step, that is p equal to alpha 1 t and beta 1. Then this will give you the sum of all the probabilities. The final step will be, the final termination step will be the probability p equal to alpha 1 t. This is transpose and beta 1. So this is the backward algorithm. The main thing that you need to understand here in the backward and forward algorithm is that if it is alpha 2s, it indicates all the paths that ends here. If it is beta 2r, then it indicates all the paths that started from here. Only thing that you need to understand. And in the forward algorithm, we progress in this way, in the backward algorithm. The final algorithm, this is the calculation here, I must show. The final algorithm, which is actually known as the Viterbi algorithm, We'll start with this one in the next class. What the Viterbi algorithm do, it find out when an observation is given. You need to find out the sequence of the space. They are physical. For example, sunny, cloudy, rain. What is? So what we need to do, if we now consider the difference between evaluation and the decoding, what is the difference? In evaluation, we consider all paths and then we sum. In decoding, what we do? We consider all paths. We select the path with the maximum probability. And this gives the outcome of the Viterbi algorithm. So Viterbi algorithm is a very well-known algorithm, and we will just in the next class we will finish it.